Hi, today this is going to be a demo video on resistors. So today we will study about the resistors. So before going to that, let us first understand what a circuit is. So what is a circuit? Circuit is nothing but a path for current. It is a path for current. Current is a flow of electrons. Okay. So in this circuit, you can have many components. You can have some electrical component or circuit components you can have. So what are those circuit components? So these circuit components can be a battery. It can be a battery. Okay. So it is symbolized like this. It can be a cell, single cell. So it is like this. This is a positive terminal. This is negative terminal. You can also have a resistor. Okay, resistor, it is represented in this fashion. Okay, so this resistor has terminal 1 and terminal 2. I'm not going to get into other components like capacitor and all. So let's go with this. What is a resistor now? Resistor, it is that component in a circuit which actually opposes the flow of current. So this resistor opposes the flow of current. Say for example, I have a cell and I connect a resistor to this cell. Then this cell, it will have some voltage, say 6 volt. So this voltage, it drives a current in the circuit. When this current reaches this resistor, what happens? This resistor tries to oppose the flow of current. So if I have 10 ohm, the opposition is going to be more. So the unit for resistor is ohm. If it is some 100 ohm, then the opposition for current is going to be more. So more the resistance value, more will be the opposition to the current. So now in the circuit, you can make out we have potential difference, we have current, and we have resistor. So combining these quantities, we have Ohm's law. So the Ohm's law says that V is directly proportional to current. And then to remove the directional proportionality, we have IR. So this is the Ohm's law. So this is it. This is the equation which actually connects voltage, current, and resistor. Okay. Now in this component, I have used only one resistor, but we can have more than one resistor. So a circuit can have more than one resistor. Let me go here. A circuit can have more than one resistor. Okay. So now if I have two resistors, say for example, I have one resistor R1, its terminal is 1 and terminal 2. Then I have another resistor R2. I need to connect it in my circuit. So how can I connect it? So two resistors can be connected in two methods. One is series, another one is parallel. So you have series, then you have parallel. Series is end to end. What happens in series connection? I connect one end of R1. That is, I have one terminal, second terminal. Second terminal is connected to the first terminal of R1. That is, they are end to end connected. End to end connection. This is called a series connection. Okay. Then in parallel, it is going to be different. So if I have two resistors, say R1 and then R2. So first terminal is actually going to be connected to one common point, say A. The other terminal, maybe the second terminal, is going to get connected to the another common point B. So here it is not end-to-end connected. So it is connected between two common points. So here connected between two common points. So this is parallel connection. So now what happens to the total resistance here? So I have connected two resistors. So what is going to be the total resistance? So in a series, what happens to the total RT? You're just going to add it. It is going to become R1 plus R2. Let me call this as RS because it is in series. Okay. But whereas in parallel, the addition or the total resistor is given by Rp equal to 1 by R1 plus 1 by R2. So P stands for parallel. This S stands for series. So if I have n number of resistors, then the total resistance in a circuit is going to be R1 plus R2. The addition is going to go like this, so it's going to be Rn. Okay. Similarly, for parallel connection, you have 1 by Rp. You're going to have 1 by R1 plus 1 by R2. It will go till the nth resistance. So this is going to be the total resistance in both series and parallel connection. Now, what happens to the quantity I and V in this? So say for example, I have a battery and I connect two resistors here. So I have R1 and I have R2. What happens to the current? So this battery gives current I. So same current flows through both the resistor. So the current is going to be same in series connection. Current is going to be same. Now this battery offers a voltage V, say for example V. But what about the voltage across R1 and R2? That is not going to be V, that is going to be different. So voltage across R1, it is going to be V1. Voltage across R2, it is going to be V2. Okay, so here current will be same, but voltage current will be same through R1, R2. But voltage, it is going to be different. The voltage across R1 is V1, R2 is V2. So what happens in parallel connection? So say for example, I have V here. So parallel, it is connected in this way. So current passes here, you have R1 and you have R2. So they are connected between two common points A and B. So when I reaches here, I gets divided into two branches. It gets divided as I1 and I2. So the current through R1 and R2 are different. So in parallel connection, I is going to be different. But what about V? V is going to be same. Okay. So voltage, it is going to be same. So in series connection, the total resistance is given by addition of the resistors. But in parallel connection, it is you are going to reciprocate the resistor and add it. And in series connection, current is going to be same, but voltage is going to be different. Whereas in parallel connection, current is going to be different, but voltage is going to be same. Now we will look into some two problems we will look into it. Okay. So I have one problem. So let me just write that problem. So this is actually a repeated problem. So if I have 3-volt battery, 3-volt battery with negligible internal resistance. Okay. Internal resistance. Connected in a circuit. Okay. In a circuit. The current I is A 1 ampere, B 1.5 ampere, C 2 ampere, D 1 by 3 ampere. And the circuit is going to be this. You have voltage here. You have current I going through this. You have point A From A, you have one resistor, R1, and you have R2 here, and you have R3 here. Okay, so you have A here, you have B here, and you have C here. The value of R1 is going to be 3 ohm. All the resistors are having 3 ohms. Okay, so this is going to be R3. Okay, so now you need to find the current. So now what can we say about this connection here? You can say that R3 and R2 are in series, isn't it? They are connected end to end. The second terminal is connected to first terminal of R2. So they are connected end to end. So what in this branch in this branch ACB, what happens? The total resistance is going to be R2 plus R3. So it is going to be 3 plus 3, it's going to be 6 ohm. Okay, so now this RS and R1 are parallelly connected between A and B. You can see here. So if you have A and B here, you have one branch having RS and you have another branch having R1. Isn't it? They are parallel. So we are going to find the this voltage. It is going to be 3 volt. Okay. So here I'm going to get the total resistance now. So RS and RS and R1 are in parallel. Okay. So what is going to be the total? So 1 by Rp, it is going to be 1 by Rs plus 1 by Rn. That is nothing going to be Rp equal to product of 2 divided by addition. So Rs is what? 6, R1 is 3. So that is going to be 6 plus 3, it's going to be 9. So you have 2 ohm you will have. Rp is going to be 2 ohm. So now what happens to this circuit? This whole thing is reduced to Rp. So I have an voltage here, 3 volt. Then I have current. Then the total equivalent resistor is going to be Rp. It is going to be 2 ohm. Now using Ohm's law, I can find the current easily. So it is going to be V by IR. So I is going to be 3 by 2. So that is going to be 1.5 ampere. So the correct option, it is going to be 2. So this is actually, your problem is 2003. Okay. So this is a repeated. So one more problem I'll do for this demo video. So one more problem I'm going to do. Okay, so let me, before going to that problem, let me tell about power. Okay, so whenever you have a resistor and a current passes through it, it actually dissipates some energy. Some energy is dissipated. So that is, you have power. So that power is actually given by, we have P equal to VI. This is one formula you have. Then P is equal to V square by R. Okay, so these are two things we need to remember. So the next problem is based on this power. So he says in a circuit, power dissipation is 150. Is 150 watt. Then R is, so you have A, it is going to be 2 ohm, B is going to be 6 ohm, C is going to be 5 ohm, and D is going to be 4 ohm. And the diagram which is given here is, you have R, which is connected in parallel with 2 ohm. You can see, let me call this as R1. Then we have an voltage source, 15 volt. Okay, the power is given by 150 watt. So now they have found what is R. So you need to find R. So for that, first let us use this power formula. So we have V square divided by R. Okay, this is going to be Rp. Okay, so Rp is what? Rp is the parallel connection of R and 2 ohm. So it is going to be 2R divided by R plus. Okay, so now I can substitute all the value. P is going to be 150, V is going to be 15 square, then I have RP. So RP is going to be 150 by 15 square. Okay, so that is going to be 1.5. Okay, so now RP is what this? So if I substitute this to R by plus 2 equal to 1.5, I'm actually going to solve for R. So now what happens? So 2R by 1.5 equal to R plus 2. Okay. So this is going to be 1.3 R equal to R plus 2. So you're going to have 0.3 R equal to 2. So R is going to be 2 by 0.3. It is going to be 6.6 ohm. Okay, so the answer is actually going to be B, 6 ohm. So this question is actually AI 2002. Okay, so I'm stopping my demo video here. Thank you very much.